One temptation when we begin with a formal system like Fitch is to try to get what we're trying to prove by just cranking out as many things as we can, hoping that sooner or later we stumble upon what we were actually trying to prove. The problem with this method is that it's unreliable, it's time-consuming, and often it's very frustrating. So in this lecture, we're just going to talk briefly about strategy and tactics for constructing proofs. There's a very real temptation to just go cranking out theorems hoping that you're going to come across the thing that you wanted. Sometimes this works, but often enough to matter, it really doesn't. And there are better ways, less mechanical ways, of arriving at the conclusion. So Barwise and Etchemendy give a maxim, which I think is worth writing out here. So it really pays to think about what the sentences actually mean. This can be really helpful with the technique of giving an informal proof and the further technique of working backwards. Let's see all of these in action. So suppose that we're asked to show that not P or Q entails not P and not Q. It's a worthwhile exercise just to pause and take a minute to think about whether you think this is actually valid. It is recognizably one of our De Morgan's laws, but giving an informal proof is a really nice way of convincing yourself that this actually follows. One way of doing this is to think about what the sentences actually mean. This is our maxim. By plugging in sentences and seeing what comes of the whole thing. Looking at our premise, suppose that it's not the case that we're going to the movies or we're going bowling. It seems as though if that's true, then we aren't going to the movies and we aren't going bowling. Maybe you don't like these examples. I would encourage you to come up with ones of your own that you find more compelling, whatever works for you. We could give an informal proof saying, well, suppose that P or Q is false. Then, granted the truth conditions for P or Q, which are true just in case one or the other is true or both of them are true, then it has to be that the whole thing comes out false in all cases except where P or Q are false. And that seems to be precisely what goes on in not P and not Q. If you like, you can construct a truth table to see why it is that the truth conditions are the same. And truth tables can be very valuable tools in thinking about these informal proofs. But let's go on to the final technique and try working backwards. We need to ask ourselves, well, supposing that we wanted to get not P and not Q, what would our lines right above it look like? And I think the best way to think about it is this. We want a conjunction, and so we want the conjuncts right here that we can just use for our conjunction introduction. Okay, so this is our new goal, is to derive not P and to derive not Q. Now we know how to do this. We assume not P for the first, and we know we want to derive the falsum. We would do the same with Q. So that will give us not P, and we would do the same with not Q, and the proof would be pretty similar. I'm going to leave this part here as an exercise, but this part will prove. So we're assuming not P with the goal of deriving a contradiction. Well, not P gets us P by negation elimination. I'm going to set aside citing line numbers for now because I think it's pretty straightforward. From P, we're allowed to derive P or Q by disjunction introduction. But wait, this contradicts our premise. And this entitles us to introduce the falsum right here. Now we're cooking with gas. The proof of not Q from not Q and the derivation of a falsum is almost identical, and I'm just going to leave it to you if you're curious. But the whole thing is just meant to be an illustration of the effectiveness of this technique of working backwards. We looked here and we said, okay, we want a conjunction, which means we want each of the conjuncts. We looked at each of the conjuncts, we recognized a negation, and so we said, well, given that we want a negation, we need to assume the opposite of what we're going for and derive the falsum right here. One of the nice things about logic then is that you're free to work backwards from where you want to go in a way that you're not entitled to do, say, with those mazes on paper that you're supposed to trace through. This is a really effective technique, and I would strongly encourage you to use it because sooner or later it happens to all of us. We look at a set of premises and a conclusion we're trying to derive, and it's just not immediately obvious how to get from the first to the second, so to speak, from A to B. And in such instances, you're always free to work backwards.